All right, let's give everyone a minute to join. Cool. While everyone's joining, maybe I can just quickly talk over a few things. Yeah, thank you so much, Reki, Dory, and CL for inviting our company Greybeam to join this Data Valentines. I think this is going to be a very exciting week for a lot of data folks. There's really cool companies like BioPlan and DLT, and of course Database Tycoon, who are also up this week, and I hope you all get to check them out. Now, before we get started, the GitHub repo here is public, so let me make sure that this gets shared for those who want to follow along either now or maybe once they get some time. In this particular repo, there is just a README file and a bunch of screenshots and a private key. The private key is used to actually authenticate into a Snowflake environment that we've set up so that everyone gets a chance to actually trial this out. I know, it's hard to find real data to do some of these webinars on, and we want to make sure that everyone actually gets a chance to, be hands-on for this particular webinar. So, with that being said, I'll do a quick round of introductions, and then let's just dive right into it. So, my name is Kyle. I am the co-founder and CEO of a company called Greybeam. And what Greybeam does is that we deploy multi-engine query infrastructure. It's a lot of buzzwords, but effectively we provide infrastructure so that folks who are using Snowflake can interact and run their workloads with other query engines. The query engine that we support today is just DuckDB. So you might imagine most of our customers are coming to us with their read-only applications like business intelligence tools, or maybe their product analytics or the application. All these tools might be reading from Snowflake, and reading from Snowflake obviously can cost quite a bit, and DuckDB can do much of the same things at a far, far cheaper cost. So companies would plug their tools into us, and we provide the DuckDB infrastructure and the routing layer and the translation layer to effectively route and execute all those queries on DuckDB whenever possible. We always default back to Snowflake if something isn't possible to execute on DuckDB, and our customers will save on average 86%, and they'll get queries coming back much, much faster. So, that being said, our challenge for today is obviously going to be centered around interoperability, being more open, very cutely entitled Dear Snowflake, I want an open relationship, and that relationship I want is with DuckDB and other query engines that we have on the roadmap. So this challenge today is very near and dear to my heart. Prior to my job here as co-founder at Greybeam, I actually used to lead data at 2 different startups. And if you're a analytics engineer or even a data engineer or data scientist or head of data or really anyone in the data team, you probably have gotten asked before, hey, why don't these numbers match? So for the challenge today, it's the end of November 2025, and your CEO pulls together some revenue data that an engineer gets for them, and he messages the data team, why don't these numbers match? So on the data team, you check Snowflake, you check your Google Sheets that the CFO sent you, and yeah, okay, the numbers are actually different. But the final question is, how do you actually check the raw data feeds? Do I have to ask the engineering team? And not just that, how do I reconcile the data across 3 different systems? Snowflake can really only query the data inside of it. Maybe it can query iceberg tables. So how do I actually query Google Sheets without first building a 5-tran pipeline or Airbyte or DLT or Mattia or any other ETL tool? Because I'm really just doing this one-time analysis. Well, today it's possible, and I will show you how to do that with DuckDB, and then obviously a very quick bonus on how it's much, much easier to do this through Greybeam. So before we get started, let me make sure again that this repo is shared with those who have just joined. And if you haven't installed DuckDB yet, make sure you do. We are using version 1.4.3, I believe, but any version beyond 1.4 should work. You'll also need to install the ADBC driver, and if you don't know what ADBC is, you can think of it as the column format cousin to JDBC and ODBC drivers. Effectively, all these core data warehouses like Snowflake, BigQuery, and Databricks, they're all column-oriented databases, and so is DuckDB. So you can imagine that if we're transferring data, we should transfer them in column-oriented storage. JDBC and ODBC aren't like that. they are row oriented. So what happens when you're using those drivers is that there has to be some, it's called serialization and deserialization, that effectively converts this column format into row format and then back into column format at the destination query engine. What Arrow does is it actually lets you keep that data in Arrow format, which is column oriented. So when you are doing data transfers between these two data warehouses that use column oriented storage, there's no costly serialization and deserialization between them. So you need to make sure you use the ADBC driver, otherwise you won't be able to connect to Snowflake later on. So once you have DuckDB installed, that's a very crucial step. You will then need to copy one of these commands. If you're using Windows, it'll be this one. If you're using Linux or Mac, you can use either of these two. Let's just use the curl on top. So what I would do is open that up. I was testing something earlier, and this is not an important key, so you can't really use it. And I will just paste it in here, hit enter, and effectively what it'll do is detect which DuckDB version we're using, then install the correct ADBC driver into the extensions directory. Awesome. Now that that's done, we can actually begin with the exercise. So what do we first want to do? Well, let's first take a look at the Google Sheet that the CFO sent us. So I have this Google Sheet, and this is also publicly available, so I'll make sure that I share this with everybody. And it's just revenue numbers for November. Nothing amiss. Just total is 107 million. Awesome. Now that we know that, we want to double check what Snowflake looks like. So I actually have a hex dashboard, and the sample data is here. We haven't been able to sum anything yet, but I'll show you how to do that shortly. And then finally, how do we actually take a look at the API data? I have no idea, and maybe we'll find out soon. Cool. So let's boot up a terminal and open DuckDB. I'm going to use Cursor for that. And this is basically just the same repo, except I'm in Cursor. And let's open DuckDB. And once you open DuckDB, it'll look something like this. So in the beginning, it's very common to install extensions. And actually, even before I install extensions, I'm going to make sure I set my time zone to UTC, otherwise that might mess up our little webinar here. And after I do that, let's first install the Snowflake extension. We'll also install an HTTPS extension. This will allow us to hit that API, or it'll allow us to make HTTP requests. And then finally, let's install the Google Sheets extension. Now, to actually be able to read from a Google Sheet, we need to create a secret. There's a few ways to authenticate. This is going to be the most easiest one. So all I'm going to do is hit create secret, and then this should open up a Google window where I'll need to log in and grab an access token, which was revealed as I went to the cursor. So I'll copy that and hit enter. Success is true. Once we authenticate, let's run a query against the Google Sheet. In the GitHub repo, I have the same query here, so all you can do is just copy it. I have it in my cursor IDE, and I'll just run the query. Would you look at that? We are able to query our Google Sheets with just a few lines of code. Super cool. Now, for a little added fun, I'm also going to make sure I turn timer on so I can see the query times. And next, let's query that same Snowflake data. So in order for us to do that, again, we can make sure we follow along, but first, make sure you download that Valentine's key that is in this repo. Once you do that, you're going to copy this command and make sure you update your path to where you download that Valentine's key. Everything else you can keep the same. This is an account that we spun up for everyone here. This is a service account, and we put this data inside the Greybeam database using the Valentine's warehouse. So let's copy that, take it to our terminal, and set up our second secret, which is the key for us to authenticate to Snowflake. And once that's done, we will actually connect to the Snowflake database. If you actually do want to use this kind of Snowflake authentication into the future, the database here is very important because this is going to be your default namespace for all queries. I actually don't think you're able to change this, so if you wanted to, you have to create a second secret for you to authenticate through to query across different databases inside Snowflake. So once that's done, in order for us to actually establish a connection to Snowflake, you're going to actually attach the Snowflake database by passing in that key. So we're going to do that right now and hope it works. Cool. So let's run it. Once you get all this and there's no errors, it means you succeeded in connecting to Snowflake. And before we continue, let's actually run a query against that Snowflake database. So I have one here that's just select star Snowflake DB Valentine's revenue raw 2025 _11, and we'll hit run. Cool. And it looks like that. I think it's pretty hard to see, but we'll open a very cool DuckDB UI afterwards. The final step is querying that raw kind of data storage API. And in order for us to do that, it's pretty straightforward. We have a URL where the data is stored. In this case, it's in parquet format. And we can actually just pass that entire URL in as a single quoted string. So let's try and see what happens. Rerun it. Boom. On your end, you might have gotten an HTTP GET error, and this is because this particular endpoint actually has certain rate limits. So as we continue on this demo today, we actually might not even be able to run queries against this if all of us are hitting the API at the same time. Sweet. So now that we established our connection to Google Sheets, we established a connection to Snowflake, we can query the actual raw data feed from this CloudFront endpoint. Let's start digging into the analysis. So if you keep scrolling down here, there is a command called call start UI, and this entire time we've actually been running this demo so far inside the CLI interface, and doing data analysis here. If you have a fairly wide table, I can't actually see these columns, so using the DuckDB UI is actually saves us a ton of time. So in order for us to do that, we will type in call start _UI, open parentheses, close parentheses, and hit enter. What that's going to do is open up a notebook-like interface inside here. And let's just open that. So the first thing that we're going to do is we are going to aggregate data on, just in total. And we want to see, is Snowflake actually different from the raw source? And is the raw source different from the Google Sheets? What's wrong here? So I have a query here that does that. It aggregates everything by the month for November, and then we end up joining all of that against the raw feed, because hopefully the raw feed is going to be the source truth. So let's hit enter, and that will run, and unfortunately we do not have the raw data table name, and this is because I skipped the first 3 cells. So in order for us to actually make calling these functions or executing these SQL scripts a little easier, we're going to make sure we create views first. So I'm going to create a view for the raw data feed. I'm going to create a view for the Google Sheets data. And I believe I should also have a view for the Snowflake data, which is not here. So let me just create that right now. So this should be create or replace view Snowflake data as, and that should do it. Cool. So now that that's done, let's try to rerun our query again, and take this in for a sec. We are querying Google Sheets data, we're querying some HTTPS endpoint, and we're also querying Snowflake, all in the same query, of course running through DuckDB. And what are the results? So we have our raw data feed as 107 million. We have our Google Sheets also at 107 million. But oh no, Snowflake is at 106 million. So unfortunately, our CFO is correct. And what are we going to do? Well, let's take a look to see what's wrong, right? We have pretty granular data here, but before I do some intense analysis, my first thought is to actually look at the daily data. So I have a query here that aggregates the revenue data to a daily grain, and then we'll compare it against the raw data feeds. Let's hit run. Here it is. So we have something that looks like this, and for some reason everything is off, and I suspect this is because I did not set my time zone to UTC, and let's try that again. The one issue in DuckDB is that time zones are very finicky, or I guess it's like that with querying across systems. So you want to make sure that you're always on a consistent time zone across every system. So if I rerun that query after I set my time zone correctly, we have that November 27th, there is a difference in revenue. So in Google Sheets, we have 1.9 million, 1.93 million, and then we also have 1.93 million from our raw data feeds, but in Snowflake it's 1.90 million. So there's something up with the data on the 27th, and let's continue digging. So now I have a query that is pulling the raw data feeds. We're going to join that by the vendor ID using the pickup time. And if you actually take a look at the granular data, the unique key across all data sets are the vendor ID and the pickup time, because the actual underlying data is a taxi data set. So a vendor in this case is one taxi cab, and it's impossible for them to pick up multiple people at once, ideally, unless you're Uber and you do Uber share. So let's run this data, and what we're trying to do is join the line level data against Snowflake, and we're trying to find where it doesn't actually exist in Snowflake. So in this case, we have November 27th, and there it is. If you see on the left, everything is vendor ID 7. So it seems like on the 27th, there might have been some kind of botched ETL job, and it's not actually feeding in the vendor ID vendor ID 7 on the 27th. And we can hopefully confidently report back to the CFO that yes, unfortunately the Snowflake data is incorrect, and we will make sure that we can backfill this data inside. Back in my day, when I was just using Snowflake, doing this kind of analysis would involve me pulling data from Snowflake into CSV, and then I'd have to pull the data from the feed, and then also download the underlying data from the Google Sheets. And if I even tried to do that in Excel or Google Sheets, it'd be impossible, because I think there's 4 million records, and Excel and Google Sheets only go up to 1 million. So doing some of this now in DuckDB with just a few lines of code is so simple, and hopefully you all get to try it yourself. Now, before I open this up to any questions, I do want to show you how all this actually is possible in Greybeam as well. So we will navigate back to our Hex dashboard. In this case, we are connected to our Snowflake Greybeam account. As I showed you earlier, we can actually execute the query. And when I execute the query here, hopefully if it's not running off of the Hex cache, it will look something like this. So in this case, this is our Greybeam front end. There's a lot of failures because I was testing a number of things, but this is a query that we just ran, right? Select star from demo DB Valentine's revenue raw. You can actually see the transpiled text here and any additional metadata. Now, the one interesting thing about this query history is that you can actually see the query engine that it ran on. In this case, this first query ran on DuckDB, and it took 350 milliseconds to run. Now next, we are still connected to our Greybeam Snowflake account, and the actual connection is directly to Snowflake by proxying through Greybeam. But even then, we're able to actually run these kind of DuckDB-esque queries on it. So if I ran this in Snowflake, you actually wouldn't be able to run it, right? So let me actually very quickly show you. So if I come back here, we have a global platform switch. And if it's on, that means we're going to route queries to DuckDB whenever possible. If it's off, then everything is going to go back to Snowflake. So if I turn that off, let's actually just run my original Snowflake query again. I'll navigate back to my front end. This time if I refresh, it will run on Snowflake and unfortunately fail for whatever reason. I'm not going to try to debug that. And now let's come to my HTTP feed query, and let's also try to run that. And again, there's another error, and this is expected, right? Obviously, you can't run read parquet inside Snowflake. There's unexpected, open parentheses. Now let's turn this back on, and I'll come back to the same query, and I'll hit enter again. This time, because it's on, it's going to say, oh, I'm going to route queries to DuckDB whenever possible, and there you go. This is the exact parquet data we were looking at earlier. And if I come back to my front end, refresh again, it's going to say, okay, well, I routed this query to DuckDB. Obviously, read parquet is a DuckDB only function, and it'll execute there. And then, the final chef's kiss, of course, is to be able to run the Google Sheets data. So this is the exact same Google Sheets that we were running earlier, and I'll just hit enter and hopefully be able to pull that data again. And I think it is done. Let's come back to our front end, and there we go. Well, actually, no, this looks like it actually just ran from cache. Maybe I can add limit 10. And that should be a new query. There you go. So now I have my Google Sheets data, my HTTPS data, and also my Snowflake data all in one single point of API. I don't have to fiddle with different extensions. I can run queries against my Snowflake data. I can then also use DuckDB specific functions that were previously inaccessible to most Snowflake users. And then now also, whenever possible, my queries are going to execute on DuckDB. And if it does, then it doesn't turn on the Snowflake warehouse. And more often than not, this type of small data is actually going to execute much faster on DuckDB. But that's it. I hope you enjoyed the challenge. And, if you are using Snowflake and you want to look towards the world of Iceberg and, use query engines like DuckDB or StarRocks or anything else that, you might imagine, please make sure to visit greybeam.ai. And if you want to chat and learn more or have any other questions about this webinar or DuckDB or Iceberg in general, I'm always happy to answer that, and so is my team. Thank you again so much for participating, and thank you again, Reki and Dory and CL, for inviting me to join here. This was a ton of fun, and I hope you all got some value out of it. Cool. I guess, we'll open the floor up to questions now.